In this last section, studying parabolas, we're going to look at how to sketch the graphs on your own, and we're going to look at how to take an equation and then use techniques like completing the square to put it into the standard form for a parabola so that we can prove which kind of shape we have. Remember, the first two slides on this are just going to be the repeated rules that I've shown on the last couple videos, so you don't need to copy them down over and over and over again. I'm just going to have them on here for reference. So here is our first example with sketching the graph, and this one's already in the standard form for a parabola, which is nice. Sometimes you might have to change it into that correct form, which I'll show on one of the later examples though. So to begin, the first thing you'll want to do is start off by labeling what is h, k, and p. In this case, h is going to be a 2. It's the number that's always attached to x. K is going to equal 3. It's the number that's always attached to y. And don't forget to change the signs on those. And then p in this case, remember that 4p is the coefficient you see. So if you divide that by 4, in this case, p is equal to -1. So start off labeling those, and it'll be a lot easier to use your formulas for reference. Well, one of the most important parts for drawing the graph is identifying the vertex of your parabola. So for the vertex on this one, no matter which setup you have, whether it's a y² or an x², it's always going to be h comma k. So I can start off with the point 2, 3, and I'm going to go ahead and plot that point right 2 and up 3. The next thing that we need for graphing purposes is to identify the focus of our parabola. And I want to show you guys how you can start doing and finding this information without trying to memorize all the formulas. So I tried to give you guys a hint, and that was to apply the p-value to whatever's being raised to the first power. Basically, I have my vertex listed out right now, and I notice that p is affecting the x variable. It's whatever is raised to the first power, and it should be right next to it. So in this case, I'm starting with the point 2, 3, but now I'm going to add this number to the x coordinate because that's what p is next to. So if I add -1 to my x value, then this will come out to be 1, 3 as a point instead. So again, just to repeat that, figure out what p is and then add it to whatever variable is right next to it. So I added p to the x coordinate in this case. 2 plus -1 is 1. So now if I plot this point, I have 1, 3. That's the dot for my focus. Now this isn't going to be a point on the actual parabola. It just helps guide the shape of the parabola. Now the last thing I use for sketching a good shape of the parabola is the focal width. And I'm just going to abbreviate that as FW. The focal width is the 4p value. Now make sure you take the absolute value of this, but it's whatever your coefficient is. So the absolute value of -4 is +4. So what I know right now is that going around the focus, the graph should be 4 all the way across. So half of that distance up in this case, and half of that distance down in this case, now gives me enough of an idea of the shape of the parabola that I'm going to start from the vertex and then connect down through the focal width point I made, and then up through the other focal width point I made. So this is our parabola, not the prettiest one, but you get the idea. Okay, let's do the exact same thing with the second example. So I'm going to start off by labeling my h value. Now my x and y switch this time. So now h is over here. It's -2. It's always by your x. K is the one next to your y variable. So in this case, +3. And since this is 4p, don't forget to divide it by 4. P is equal to 2 in this case. So when I identify my vertex, the vertex is something that does not change, whether it's an x² or a y² parabola. So my h and k values are -2, 3. It's always h, k. Next, let's identify the focus. And remember, I'm trying to show you guys how to do this without having to look at the formulas at all, but if you need to use them, go for it. So in this case, p is next to the y variable. So I'm going to take the p value and add it to my y coordinate. So it used to be -2, 3. If I add 2 to the y coordinate, 3 plus 2 is 5. And then I can go ahead and plot these 2 points. So I have -2, 5, and then the other one from my vertex was -2, 3. The last thing that we need to identify here is the focal width. So how wide is the parabola passing through the focus? That's why it's called the focal width through the focus. In this case, it is a width of 8. So I'm going to go half that distance in either direction. Remember, the parabola starts from the vertex, and then if I go halfway over, if the whole width all the way across is 8, then that means in each direction it's only 4 across. So 4 that way, and it'll go off the graph a little bit, but that's fine. You can always just kind of extend your X and Y axis there a little bit. So then I need to go from the vertex and then just touch through those focal width points that I made. So remember, the idea is that the graph doesn't actually touch the focus. The focus is just kind of an important piece of the graph in terms of shaping where is the parabola going. It's going to go around and towards that focus, but it doesn't actually touch it. For our last type of example, our last concept, and we're going to be doing this with all the shapes, so you might want to brush up on how to use completing the square on this. We are going to change this from the current form into the standard form of a parabola. So what's important to find is which variable is being raised to the second power. You want to get that, all the stuff with that variable in it, on the same side of the equation. So I'm going to rewrite this as y squared plus 2y, because it's already on the same side, so I don't have to move anything there. But everything else needs to move to the opposite side of the equation. I'm going to leave a blank space here, and I'll fill that in a moment. So if I'm moving 6x to the opposite side of the equal symbol, that means I'm adding 6x to the other side. This 13 is also getting moved over, so that means I need to subtract 13 to get it on the other side. And so this next part is going to be the actual completing the square piece. To do this, when you have your squared and your first power variables, you take half of the middle number, half of this. So in this case, half of that is 1. So half of b. And then the next step is going to be to square that. So remember, it's x squared plus bx plus c. So that's why I'm referring to this middle variable as a b, because b is the one we attached to the first power variable. So half of the middle number squared. In this case, if you take half of 2, that would be 1. If you square it, that's still 1. And so it seems weird, but we just decide that adding 1 to both sides of the equation will help us in some way. And the reason it helps us is because by using this process, the trinomial you have on the left-hand side will always break down to be y and whatever half of the middle number was. In this case, half of the middle number and that number squared are the exact same thing, so be careful about this. It's just the half of the middle number that gets written into the factor. And so sure enough, if you actually distributed out y plus 1 times y plus 1, it would come to y squared plus 2y plus 1. So the reason we added 1 to both sides of the equation was so that this stuff on the left-hand side would factor down nicely, because now it matches our standard form for a parabola. On the right-hand side, all we have to do over there is combine the like terms. So 6x doesn't have any like terms, but -13 plus 1 is equal to -12. So we're almost there. There's one more piece that we need to, one more step that we need to perform here. The left side is finished, so I'm going to leave that as y plus 1 squared. But on this right-hand side, I see that there's a GCF that I can factor out of here. So I'm going to take 6 out of both of those terms, which would leave me with x minus 2. So if I distributed this back out, it would be 6x minus 12, which is what I had originally. So now if you compare this to our standard form of a parabola, we can see that we have our h value, our k value, and our p value. So I'll go ahead and label those. H is equal to 2, k is equal to -1, and 4p is equal to 6. So if you take the fraction 6 and divide it by 4, and then reduce, so 6 over 4 and reduce that, you'll have 3 over 2. So now we have our three values. We've already proven that it is a parabola because I have the standard form of a parabola here. So the next part of the directions was to go back to what we've been doing in the past, labeling the vertex, focus, and directrix. So my vertex is going to be h comma k, so 2 comma negative 1. The focus, this one will be a little bit more painful because I'm getting a fraction on this. So I'll write this out to show you the steps. Remember, whatever p is attached to, so in this case it's attached to x, that's where I need to add the number. So in this case, since p is coming from the x variable, I'm going to add p to my x. So 3 halves plus 2. And then the other value just stays as it is, the negative 1. So I didn't simplify it because I wanted you to see where this number was going to come from. Remember, if you try to add or subtract fractions, you have to have a common denominator. So think of this as 4 over 2 plus 3 over 2, which means my focus will be 7 over 2, comma negative 1. And then the last piece is the directrix. And the same kind of system I was showing you for the focus, since p is next to x, it's still going to affect that same value, that same variable. So it's going to be an x equation. So I'm going to say x equals, but the formula is whatever your value was. So in this case, it's my h value, but I'm subtracting p this time. So 2 minus 3 halves. And then if you evaluate this, that will leave me with x is equal to, and by getting a common denominator, 4 over 2 minus 3 over 2 is 1 over 2. So again, you'll start to notice that this is not about me memorizing the formulas for focus and directrix. It's more just about me starting to pay more attention to the fact that p is next to x, so it affects my x coordinate of my vertex. You either add it to it, which is what you do for the focus, or you subtract it from it for the directrix. And your directrix answer is that entire thing. It's not just 1/2, it's the line for x equals 1/2. So that's it for the notes. Hopefully that'll be helpful for you guys on the examples. Thank you.